This is some feedback for Evaluative Task 1 from 2009. So just be aware that you're provided with an equation in the beginning, and the stoichiometry, as you can see, is 1 to 2 to 1 to 1 as we move from the zinc to the HCl. Further information on the procedure underneath, and then some results at the bottom in a table giving you each individual student the initial temperature of the mixture and then the highest temperature that was reached. And you can see the first thing that I've done here is to calculate the temperature change for each of those, and I've just added it on into the middle, or I could have added a column at the end. The first question is asking, explain one advantage of comparing the results of the 5 different students. The answer to this is always the same, and it was the same at GCSE in your AQA ISAs, and it is to identify anomalous results. B, the student wanted to calculate the enthalpy change of the reaction. Calculate the average temperature rise, delta T, that they should use. You can see that I've used the numbers 5 plus 5 plus 6 plus 6 and divided that through by 4 to give me an average of 5.5. I haven't included units because the units are already indicated for me, as you can see just here. The reason that I've chosen to use these 4 values is because these are the 4 values that are similar, so reasonably concordant. You can see from the value that I've calculated for number 2, for student number 2, that the number is 3, which is evidently an anomaly. And when we calculate mean values, we always exclude the anomaly in the average that we calculate. We then have to calculate the energy change in joules. So we use the equation Q equals mCt. We're using 50 because we have got 50 grams of the solution. We are using 4.2 because that is indicated to us as a specific heat capacity, and we are using 5.5 because that is our temperature change as indicated in part 1 that we calculated. If you have a different value here and you've used it here, your number here may be different, but you can still get error carried forward marks. The answer is 1155 joules, and again, I don't need to indicate a unit because it's included for me. The next calculation is to do with moles. Show that the students used an excess of zinc by calculating the minimum mass of zinc required to react with the HCl. So if we use our standard equation of N equals M over M and rearrange that to make mass the subject, we take the number of moles and multiply that through by the molar mass of zinc, which is 65.4. The reason that we know we have 0.05 moles is because we have got 0.1 moles of HCl, and as we mentioned earlier, the stoichiometry of the equation is a 1 to 2. So in this case, we're dividing through the 0.1 value from the hydrochloric acid through to get our 0.05 for our zinc. The answer here is 3.27, and again, units are already included. As we go down to question 5, the enthalpy change in kilojoules for the reaction of 1 mole of zinc with 2 moles of HCl. The most common error here is to not pay attention to this piece of information, which is then repeated here. We also need to give our answer to 2 significant figures. So if we use our standard equation, we're taking the enthalpy change, and that enthalpy change, which we calculated here, is representing the enthalpy change for 0.05 moles of zinc. So I've taken my value, I've divided through by the number of moles of zinc that I would use, which gives me 23,100 joules. This is joules, not kilojoules. So I have to remember to divide through by 1,000, which would give me 23.1. And then I have to remember that it's to 2 significant figures, so I need to get rid of the 1 and round correctly to get my minus 23. This is our target, to get 1 mole of zinc, okay, because it's asking us in the question for 1 mole of zinc, 2 moles of HCl. Flipping over to the next slide. Students evaluated the procedure and the apparatus that was used, the main error, and suggest how to modify the apparatus. The main error is heat loss, as would be with any enthalpy calculation, and suggest how to modify it. Now, a lot of you might put to have a lid, and that is correct, but it's not credit worthy at A level, well, on this particular paper. Adding a lid is going to potentially reduce the error, but not by as much as insulating by lagging or using a polystyrene cup would. So these are the 2 things that you need to get the mark, the single mark for that question. We then have a question on errors, which is becoming more and more popular. We've got student 1, specifically student 1, is evaluating her experiment for accuracy. The data that we have, we are using 50 centimetres cubed of HCl. Please don't get this confused and think that it's 100 centimetres cubed because she is using a 100 centimetre cube measuring cylinder. So it doesn't matter how big the measuring cylinder is, what matters is how much we're actually measuring out. We can see that it's read to the nearest 1 centimetre. And then we can see that the thermometer she's using can be read to the nearest 0.5 degrees Celsius. So if we look at the question, calculate the percentage error in the volume of HCl measured in this experiment. We take 1, because this is our error, divide it through the quantity that we are measuring, 50, and multiply by 100 to get it as a percentage, so 2%. The next question, calculate the percentage error in the temperature rise measured by student 1 to show that it's a more significant error than the volume that she measured. Now in this case we have got 0.5, which is our error from here, and we are multiplying it through by 2 because to calculate our temperature we had to take 2 readings. We had to take our beginning reading, 17, and our final reading, 22. And because we've taken 2 readings, our error is therefore doubled. We divide through by 5, which is the total temperature change that she calculated, and then we multiply it by 100 to turn it into a percentage, and this will give us an answer of 20%. Now if you do have access to the mark scheme, you'll notice that the mark scheme actually has an error on it. It tells us to divide through by 5.5. This isn't correct because 5.5 is the average of all of the students who did the experiment, and it gives us 18%. The question explicitly states that we need to calculate the percentage error for student 1 and only student 1. The next question is one that you're familiar with from GCSE, and it's quite simply a rates of reaction question. I've got here the 2 lines indicated, and I'll talk you through them in just a second. The temperature reaches a maximum and then falls. Explain why. Now, if this was me, the most important thing that I would write is losing heat to the surroundings. So the reason that we're dropping down here at the end is because heat is being lost to the surroundings. Now, to get the mark, you also have to write that the reaction has completed. Now, if you think this through logically, it does make sense that you have to write that, because at every point on this curve, heat is being lost to the surroundings, but the temperature is still going up. And the reason that the temperature is still going up is because the reaction is still proceeding. And therefore, it's releasing more heat than it is losing. But when the reaction has completed, approximately here, after that point, no more heat energy is released by the reaction, and therefore heat is lost to the surroundings. So it's important to get both of those things included. We've then got modifications to the experiment, and 2 of them. Line A is using 10 grams, the same quantity of powdered zinc, but we are now using it, rather than foil, we're using powder. All this does is increase the surface area. If we increase the surface area, we have a faster rate of reaction, and a faster rate of reaction is always indicated by a steeper gradient, and then it plateaus off at the same level. The reason that it's plateauing off at the same temperature rise is because we are starting with the same quantity, 10 grams, of reactants. So there are 2 things that you have to have for this mark: a steeper gradient and levelling off at the same final temperature rise. You may then follow your line through and have a decline as heat is lost to the surroundings. The last mark comes from line B. We've got the addition of the HCl, and we're using 100 centimetres cubed instead of 50 centimetres cubed. Now if we're using 100 centimetres cubed instead of 50 centimetres cubed, the line that we should see we've got indicated here as B.